My name's Thomas Guest. This talk is about Boost. At this stage, all I'm going to say is that it's a big collection of C++ libraries. It's where some of the standard libraries grew up, and it's where some of the standard libraries are going to take inspiration from. And it's a whole lot more, but we'll get into that. I do have a website. That's my Twitter handle, the thing with the @ on it. And I work for a company who also has a Twitter handle. And the reason I mention them is because I'm going to be giving context to this by talking about the applications we write. So I don't want to be talking about Fibonacci or foo and bar. I want to be talking about real applications. Thank you for coming. I just wanted to say how I got here. This is going to be brief, and it allows people that are grabbing a coffee to come through the back door. November the 18th last year was my 55th birthday. So November the 17th, there was a race on in Swansea, in South Wales, which is where I live. It was a cross-country home international, and I was eligible for the V50 to 55 age group, being 54. And unfortunately, my performances weren't good enough, so I didn't get selected. Now, the thing about, I got put on the reserve list. The thing about veteran runners, they don't lose their speed. They lose their speed only gradually. Their competitive urge grows up, gets ever more, but they do tend to be prone to injury. So I realized as reserve, there was a chance I'd be called up. And so it turned out, 2 days before, Bernie Jones, the team manager, emailed me and said, Thomas, are you still able to run? We've had someone drop out of the 45 age category, which is why there's a 45 on my race number. I didn't hesitate. I wasn't going to miss this opportunity. The race goes all around the sort of home nations. This was the one time it was in my city. So I turned up on the 17th, day before my birthday, at the start line. I had a look around. I was looking for people that were had a bandage on their knee or coughing a lot or maybe a little bit overweight. Not a chance. Everyone looked like whippets. I felt positively ancient and flabby. And I realized that I might not come, well, I might be at the back of the race, and so it was. By the first lap, I was at the back of the group, and for the remaining 2 of the 3 laps, I was trailing, not by much. Do you know what? I absolutely loved it. If you're going to be at the back of the race, you might be right at the back, particularly if you're wearing a Welsh vest. I got cheered all the way round. It's a special thing. In the Tour de France, they have a position called Lanterne Rouge for the last rider. And that's quite hard to defend because you have to be within the cutout, but still the last overall. It wasn't quite the situation here. Anyway, this is the reason I mention this is because at the same time I had this talk proposal with the ACCU conference committee. And come the new year, when they selected the talks, they said, "Thank you for your proposal. Unfortunately, the quality of submissions is so high that we haven't been able to fit you into the program. It's very rare, but you are on a reserve list. Sometimes people do drop out." Now, I don't know about the rate of dropout for conference talks, but to my surprise, about 4 weeks ago, I got asked, "Are you still willing to do the talk?" This time I hesitated, not because I didn't want to, but because I hadn't done it before, and I hadn't actually fully written it. The ideas were there. A lot of ideas going to put in the proposal together. But in the end, I thought back to November the 18th, and I thought, you know what? I'm going to defend being the last place. I'm going to step forward. I'm not Herb Sutter. I'm not Kevlin Henney. But there's something I have to say, and I'll invite you to sort of cheer me all the way round. Anyway. So, another little story. I don't know if you can see this picture. It's an interview situation. This is from 3 years ago. I was working with Ed at the time in Bristol for a company, SN Systems, and I was looking for another job. I was heading over to South Wales for an interview, and I remember because England were playing Wales in the European Cup. It was an unusual interview. I wanted to just introduce the people in the picture because I will. I'm the person down at the bottom there with the hands like this. The slightly small person behind the keyboard is Dr. Pete Johnson. He's written much of the software that I'll be talking about as a kind of context for today. He's a trained doctor, and as some doctors tend to be, an absolute genius programmer, but he does it his own way, and he did it using Boost. The other person, the one that's meant to be female is Rian. She's product owner. So when people talk about passion in our industry, they're genuinely not right. They're meaning someone that kind of have got a bit of a spark compared to the rest. But Rian genuinely is passionate, an absolute pleasure to work with. And the larger chap who's asking the question, that's my manager and the chief architect. He's Carl Creswell. And he does most of the talking, which I'm not used to in an interview. And he comes up with this question: have you used Boost? It's a strange question to ask because it invites a binary answer. Interview questions are supposed to be open-ended. But I wanted to pose a variant of that to you. Could you stick your hand up if you've never used Boost? Okay. Now can you stick your hand up if you have ever used Boost? So that should be everyone. All right. Could you put your hand, and that includes me, hand up if you've ever contributed to Boost, either with a bug request or something more substantial, a pull request? Numbers are going down. Has anyone here written a Boost library? Oh, who are you? Congratulations. Thank you for, I'm coming out in favor of Boost, but I will have some, I'm glad to know. Put me right. Keep me honest. So given that it was an interview for a C++ job, if you're going to be asked that, you're probably going to be required to use Boost. So the answer has to be yes, I have. And it's true. As Ed can verify, when we were working together, we used a handful of libraries. And we stopped using them because they grew up. Things like Smart Pointer became in the standard library. File system, that's now grown up, but I dare say a lot of code bases still use the Boost one. It may be a little better. Things like unordered map, unordered set, they've all come from Boost. So I talked a bit about this, and I even said, you know what, there's some wacky stuff that I found in there where you can embed a BNF grammar in the source code, and it generates the parser for you. And some people sort of in the room nodded to each other. What I didn't say was my real answer, which is, yeah, I've used Boost. It can be trouble. You might find that it puts compiler warnings that every time you go to a new version, you get new ones. You may find your build times are slower than you'd like. You may find you have trouble getting it building. You may find that some of the stuff it uses isn't the most obvious. It's almost like it's seeing what you can do with C++ rather than what you should do. But what I said was, yes. What I thought was, yeah. And my attitude has changed over the past 3 years. As I say, I've come from a situation of taking an interest in Boost, either not being able to use it because it was kind of not part of it at work and using it personally, or cherry-picking bits. And now I'm in a position where I'm using it all the time. And we try and, anything that can be done by Boost, unless it's in the standard library, we do with Boost. Time for some code. And this is something, so I've gone to last year, I've gone to 3 years ago, now I'm going to, in the last month. Please, I apologize for the noise on there. I just wanted to put some code up because it's using Boost and it's saying in a sort of small example lots of the things that I'm saying in the next, I guess it's 80 minutes if I go the distance. There are 3 Boost things going on here. There's insert, filtered, transformed. And there's quite a bit of noise around that, which could be cleared away with some useful name spacing. But nonetheless, this is how the code came to me in a kind of piece of code to be merged. We're dealing with something that's not made it into the standard library yet, but I believe is on the way. We're talking about ranges. Is anyone here using these particular adapters and this style of programming, this range programming? Okay, a couple of people. So it's on its way in, and it's doing something very elegant and very clever, but there's a bit of stuff going on around it. So Boost is being used. It looks quite like the standard library in terms of its naming conventions, and indeed, in the grayed out code, you can see lots of standard library stuff playing nicely with it. There's an unordered map. There's a std function, a std pair. And I think all of these came from Boost, so it's not surprising they play nicely. By the way, I think the std function doesn't need to be there. I don't know why it was put there. And that makes me worried, but it was a bit of a moot point, as it turns out. Just to fill in the code a bit more, that's essentially what's going on without the noise. We've got a graph that has edges. That's a collection of some sort. We're then applying a filter to it through the pipe operator. So this is inspired by shell programming. So you take a collection, you pipe it through to a filter. You pull out edges which are consumes. This is something to do with consuming medication, maybe. I haven't talked about the domain. And then we pipe it through another adapter. So we're taking the range of edges, we're filtering them, and then we're transforming them. And essentially, we're inserting to from. So we're ending up with the map of edges of type consumes, and we just select it out. It's a directed graph, if you like. And we're going from the destination node to the source node for the consumes edges. So it's elegantly and declaratively written. It's noisy, but we could get rid of some of that with some name spacing. And there's some redundancy, these std functions. The real problem I had with this was that it didn't compile. In fact, it didn't link. I got a compile error at link time. I should stress this is extraordinarily rare. I've had about 2 bugs in Boost in the past. It's about 1 bug a year that I see. But nonetheless, Boost 167, if I was to click on that, well, this is a header file on my machine. You can see that this bottom piece of code is declared as returning a reference to a container, and it's just not doing it. So the obvious solution, of course, is to move to the latest version of Boost. Why did this code ever get submitted? The answer was Pete always moves ahead of the rest of us. He was on the current version, which I believe is 169. 170 coming soon. They come every 6 months. Why were we not on it? Because we hadn't made the transition to that version. Because when we did our sort of smoke testing, something else was wrong, which we haven't sorted. Unusual situation, but nonetheless, it's saying a lot of the things I want to say about Boost. It does update. It can be sort of showing the way for the standard library, and it can be trouble. This is how I rewrote the code so it would work with our compilers. It's old school, apart from it's got a range insert. I suppose the correct way to do it would be a copy if and a transform, but then you've got intermediate containers, so I just went for this. That's how you would do it in Python. We're always looking for new ways. I almost wondered if C++ will eventually end up with something a bit more like this. This is kind of almost what you want to write if you're using that pipe style, but I see so much stuff happening in C++, I'm never surprised now by what turns up. Okay, so just another quotation to say where I'm coming from. This is, I was watching a video on YouTube by Jonathan Baccara, who did a presentation at this conference, introducing one of the more out there Boost libraries, Boost Karma. And he works through one of the examples from the Karma tutorial and says exactly this. I know how complex this looks. To be honest, I haven't used it. But I think it's interesting to know what's in there to get inspiration. I've cut some stuff out. If you're looking to get a job done, maybe this isn't the way to go, is what he's saying. You know, I'm not using this myself, but I just love what it's doing. And you have to be aware when you're using these libraries, are they getting you the job done, or do you think you should be using them because this is the most advanced or clever way of doing it? So what I'm saying is that make sure you're using these libraries and they're working for you. Make sure that they're bootstrapping your application by giving really solid performance support for all those things that aren't stuff you have to write yourself. And that, by and large, is what they do. Make sure they're doing that for you. As opposed to, boo, I'm trapped by this library. It's too clever for me. So that was the introduction. The rest of this session, I'm going to briefly introduce myself, where I'm coming from. I've already done that, kind of. I'm going to talk about the company I work for and the applications, or the application area I work in, to provide context to what should be the main part of the talk, which is why we use Boost, where we use Boost, and how we use Boost. So that's where I'll switch to a code editor and compiler if I have, if the luck of the live demo is in my fingertips. And a very brief section at the end, things I'd like to see, not things that I know are coming, but things that possibly might arrive that would, be kind of nice standard components for the particular applications I work in. So I work at Clinithink in Wales. It says on the conference thing that I wrestle meaning from medical records. So that's the application area I'm in. I'll talk about that when I talk about the company. On a good day, I will go running in the morning. I'll do some puzzles in the rest of the morning, and then I'll have some noodles, probably from Chili Daddy's, which I don't know if any discovered Chili Daddy's. It's the best place for noodles. Here's the best puzzle that I've done recently. Actually, I could click through on that. Oh, I can't. Oh, it's up here. Yeah, as you can see, it's brilliant. It's 6 identical casino chips that fit in what look like a symmetrical box, and it's obvious how they have to fit in. But the sequence of rolling them around is, this is on my website, by the way, is quite astonishing. That's a dream of a puzzle, because it's both simple and it's like no other puzzle you've ever seen. Anyway, that's what I like doing. What it doesn't say is that I like programming. That goes without saying if you're attending a conference like this. It doesn't say I like C++. I do like C++. I used to like it a little bit less than I like it more. I kind of have given up trying to keep up with the language. And I love all the new things that are coming in that I don't really understand but work for me. I'm not one of the experts here, but I'm picking up the flavor of what's going on. Most of all, however, I like what I can get done with C++. For me, it's about the applications you develop and the code that's running. And it's the best tool for what we're doing, which is bulk processing of a lot of text information. So I'm looking for the bits of C++ that help me do that, okay? I'm not looking for full knowledge. I think that's almost impossible. But I'm looking for the good bits. And the same goes on for Boost. And there are lots of them. You have to make a bit of a commitment, and you have to make some sacrifices, possibly. If you're going to use templated code, face it, your build times are going to go up. Boost uses templated code, no surprise. So that's who I am. Clinithink, what do we do? We're in this picture probably isn't very clear, but it's meant to be a doctor or a clinician writing notes. They don't actually write by hand. The notes we deal with are typed in, they're digital. We don't do OCR. But physicians are trained to write down what they see in story form. So they'll say, the patient presented with this, their family history was that, and it's written in sentences, which is part of their discipline, just like we're taught to use source control or peer review or, fixed line length or that kind of thing. The result is that you get medical filing cabinets, if you like, not physical cabinets, but server racks full of this unstructured information. And it's very hard to get information, because it's unstructured, it's very hard to get meaning out. So what we do is we use we try and find what we call encodings within those records. We go to a standard structured format that can then be used to enable you to extract more meaning. So you can tell things about a population once they've been through our system by running structured queries. Very quickly then, architecture, the C++ bit is what we call an engine. You funnel in clinical narratives, turn the handle, or ideally the application turns the handle, and out at the end you put out this structured format, these encodings. External to the engine, and this is something I'll talk about with Boost, how we do this, you have configuration. Things like the thesaurus of medical terms and the description language that you're using. The way physicians talk in your particular region, which varies considerably. They don't use the thesaurus terms. They probably use something very different in North America to they do in Northumberland, for example. One of our customers is in Newcastle. So these configuration things are external to the engine, and they're very much regional dependent. So that's at the core of what we do, and that's where we use Boost, and that's where I work. That on its own isn't much use to a healthcare organization. You need some sort of application around it. And you need a lot of them because you've got typically thousands of records being created every day. And those all have to be fed into these engines. Ideally, they're kind of pushed in through an integration API. And then around the engine, we've got an application written in Python. And that's offering services via a REST API to some client applications, or we have our own applications to do with drugs trials that you can look at through a web UI. This, by the way, is almost invariably hosted on site because these medical records are privately identifiable health information protected by law. So typically, we give people the software, they install it, or we help them install it. There's also something that we call Exchange that lives in the cloud. And you can think of this as the tool shed for these tools that are being downloaded on a per-site basis. So that's the world that we live in. This is what I'm talking about when I talk about narratives or stories. This is the kind of text that we consume. You can see things like headings. That's important. So if something appears under the heading of allergy, it's very different to if it appears under the heading of history, or prescription. If you're prescribed aspirin, it's different to being allergic to aspirin. So lots of this kind of data. It's natural language processing and search engine techniques we use. I just wanted to show you, has anyone here heard of SNOMED? Oh, wow. It's actually an internationally recognized standard for the kind of description of medical things. So it's not just a dictionary of terms or even a thesaurus. It's how things can fit together and connect together. And you have a kind of structure there. I wanted to show you a few items in SNOMED. This is a bit of internal tooling that we use. If I was to search for ACCU in the SNOMED terminology, it comes up with a couple of things. And then you can start navigating your way around. You've got this hierarchy where things can have multiple parents, and it kind of throws everything in there. But it's not just the descriptions, the relationships, and the concepts. It's also the way things can be fitted together. So I wanted to show you, and it has some bizarre things, like these are the children of physical object down here. They seem like a peculiar set of siblings. You've got device, vehicle, instrument of aggression, cochlear implant dummy magnet. They don't seem to be particularly floor mat. Why not? I mean, I shouldn't mock it. This stuff is properly developed, properly supported, enormous, and very well thought out. It's one of those standards that's sophisticated, but not more sophisticated than it needs to be. There are other description languages that are more powerful, but they're just too hard to use. I just wanted to show you another comedy one that particularly amuses me. These are all the entries that search the spacecraft. One of the most important things about SNOMED is it's not just a list of things that are in there. You can combine things to make bigger things. These ones seem too big, these concepts. Normally you'd connect things together. You'd connect the sort of base terms to make bigger ones. Okay. How do we do the processing? You can almost think of it as a pipeline. Stories come in on that side. The first thing we do is take a chainsaw to them and try and get the sections out. So we try and find the family history section, or the what happened in hospital section, or the allergies section, because that context very much affects how you interpret the next level, which is segments. You can think of them as sentences. And we're looking within sentences. We do a bit of cleaning, we do a bit of spell checking, we do a bit of removing noise words like stop words like and the. And we go back to the base form of words, standard language processing techniques. And then we start applying the SNOMED to it, and we start looking for the nuggets of information. And then we create the output structure, which is packaged as the encodings. There are standard formats, but we kind of cope with whatever's thrown at us. But sometimes people throw stuff that we wouldn't expect. There are medical record systems that will have a kind of standard format. But quite often you'll see stuff that's got hideously mangled, and the text is in different encodings, and there'll be lots of cut and paste. So we have to deal with quite a lot of mess, and we're ready for it. But sometimes people will surprise us. You'll have a document that's 1 million characters, and it's got no full stop in it, and it's all on one line, and that will send our algorithm into a panic. But we're pretty resilient. I just wanted to very quickly show you what the output looks like, because it's going to inform some of the code examples I give. So how do we mark up the documents? How do we present these expressions? Well, the answer is we don't really. They're there. It's kind of an implementation detail. That's what either an integrator would use or a web application would use. But from my point of view, I'm quite interested in that. And for the subsequent code examples, I just wanted to show you how we do our document annotation. I've got some extremely small sentences here, but it will show you a little bit about the output representation that we use. I know it doesn't look terribly like it, but this is a graph structure. It's markup, and the nodes of the graph are the regions within the text. So, for example, you've got a section. So this is a single sentence. Typically, we're talking about large documents. So the section is the whole of the document. So that particular node goes from position 0 to position whatever it is, 50-something. The main node here is what's called a chunk. This is the main thing that's been identified in this text. And what you're looking at, this label that's attached to the node is a SNOMED expression. Obviously, you don't need to understand that, but that's got some human-readable bits, which are between the pipe characters. Those are the terms. So this is the SNOMED representation of what's been found in this fragment of text. And this is also a machine-readable thing, this SNOMED string. You can see it's got some sort of structure to it with stuff that's fairly familiar to programmers. You've got braces and parentheses and pipes. It's not XML. It's quite programmer-friendly. So I'll be talking about that a bit later when I'm talking about some of the parsing libraries in Boost. And then these edges, which are typed, so this chunk has an extent of the phrase, and the phrase node is here. Again, the phrase is the whole sentence. So you've got a lot of what in SNOMED terms is called post-coordination. You've got concepts in SNOMED. Anything with a C or the word concept is one of those SNOMED nuggets that I showed you, one of those things like collision of spacecraft or ACCU serialisation bandage. So this is a SNOMED expression that's been found in this piece of text that's built up from relationships with other bits of SNOMED using SNOMED's post-coordination rules. You don't need to understand it. I just wanted to, and it's represented as a graph. The graph nodes are the regions within the text. I know I'm repeating myself. The graph edges are the things with arrows that link the nodes together. So it's a very simple, flexible, generic structure that we output. And the nice thing about SNOMED is, with this multi-parent hierarchy, you could match this expression to something like finger injury. And this would say, yep, I'm a child of finger injury. Or you could match it to things caused by boiling liquid. And it would say, yep, I've been caused by hot water. So there's the hierarchical ISA relationships in SNOMED come into play. So that's probably more than I needed to go into on the technology we're using. But it's to provide context for what's following. And I hope it's interesting. One of the nice things about working in this area is that if we get it right, we're doing something important. The software can help a drug trial succeed, which can, so many drug trials fail at the initial state. And if you can aggregate this sort of information, you can work out before you even start your trial search procedure whether it's going to succeed. And then the software can help you find the candidates for the trial that are matching all the criteria for the drugs trial. Anyway, enough about that. But it's nice to be working on something that's important. I mean, before I worked primarily in, my last two jobs have been in what you could call leisure or entertainment, so digital television and then computer gaming, which is good, and certainly the software was very successful. But I started to think of computer games as being not necessarily all for the good. This was when my son was playing a game called Call of Duty, where he would get up in the morning and visit some war zone with a big weapon. Anyway, I don't do that anymore. So this is the main part of the talk now, based on what I've been saying before for context. Why do we use Boost? Well, it wasn't really my choice. When I started work on this engine, I quickly realized that when they asked me at the interview, do you use Boost? They use Boost. Specifically, Pete Johnson used Boost. I'll go through the list of things that we use it for. He has clearly digested what's in the library and decided this is the best way of doing things. And I've come round to appreciating that point of view. Sometimes they're not easy to get into, but once someone's made that step, and some of them are extremely simple. You have little things like optional that are useful, that are now in the standard library. You have big things like asynchronous communication frameworks or inter-process primitives. Graph libraries, indeed. Funnily enough, that's one of the things we only use in parts. Because, let's not get down that. So that's why we use Boost. We use it because it's enabled Pete to get this thing going with less code, more library code, more proven library code. Same reason that everyone likes to use the standard library. Boost contributed much of what's in the standard library and continues to contribute things. And sometimes it's contributing direction. Sometimes they have to use the current version of the language standard, and the C++ committee will say, we can do this better. We're going to introduce lambda functions, forget your ones. Where do we use it? I'll talk about that. How do we use it? That's the code examples. Yes, so I'll be talking, intro I've done. I'll talk about how you can install it and use it. Multiple choice. And then these were the 3 libraries that if I get chance, I'll focus on: Boost.SPIRIT, Boost Python, and Boost into Process. So I want to show code examples in 3 areas where it's really given us a boost, haha. Advantages of using Boost, I believe it's about 20. It continues to be actively developed. I think the releases come out twice a year. I've not seen anything that I relied on disappearing in that time. So some things are no longer necessary because they move into the standard library, but it takes backwards compatibility extremely seriously. So some of the libraries which do develop, they maintain a sort of old version for fans of the classic flavor. Portable, yes. I think they go to considerable efforts. As it happens, we use it on Windows and Linux, so we don't require much in the way of portability. Active, absolutely. New libraries are being added all the time. Bug requests are responded to. I don't know what to say. Peer-reviewed, yes. The license is everything you could ask for because it wants to make its way into the standard library, ideally, I suppose. And yes, it fits well with the standard library. The containers work with the standard algorithms. It's providing inspiration for and drawing inspiration from. Well, that's my take. If you like the standard library, you'll like Boost. Challenges, that's a way of saying things that, well, yeah, it's a friendly way of saying things that you need to know about. Happy 20th birthday. So C++ has grown up in 20 years. Maybe some of the libraries are using older ways of doing it, and as a consequence, maybe are slower to compile than you'd want, or just not using the most up-to-date techniques. Tough on tool chains. You might say, well, that's good. I don't mind a compiler having to work hard, but you probably mind having to wait for it. You probably mind if you get an internal compiler error, and this does happen. I guess it's not part of the sort of standard Visual Studio distribution, and sometimes it will seem like it doesn't work very nicely. It will throw up warnings. You'll just upgrade something, like your compiler, and you'll suddenly find that Boost is throwing you warnings out. And sometimes you'll get the syntax very slightly wrong, and you'll see something that was obviously a result of a macro preprocessor, and it will produce stuff like this. And you think, how did I do so bad? So being tough on tool chains, they kind of they feel the pain and they share it with you sometimes. Uncompromising. This is kind of a good and a bad way, but if there's a more performant way of doing it that's slightly more fiddly, the Boost libraries will choose that, or that's my impression. They are pushing the syntax hard. It's also a large collection of things, and sometimes those things, you don't necessarily want them all at once. You don't want to upgrade the whole lot at once, but you have to. It's very hard to pull in the latest version. I don't know how you would do it. Say you wanted the latest version of, in my case, Boost Range, but I didn't want the rest of Boost 169. Not something I was going to try and do. And at the same time, sometimes it doesn't seem to be kind of edited and collected together. You know, how can you know what's in there? What are all the different bits? It's quite hard to track in a way that some other libraries I've worked with aren't. It's high voltage, like C++. It's taking C++ and it's pushing it. And quite often you'll find compiler workarounds in the source code and things like, you know, this version of this compiler is wrong, we're going to have to do this. It's good that they've done that work for you, but it's hard to read the code sometimes when you know to go into it. It's not very Stack Overflow friendly. If you're searching for answers to questions, quite often you won't find them on Stack Overflow. I don't know why. Is it because people aren't using it? Or is it because they don't haunt those forums? Or is it because I'm using the wrong search terms? Does anyone agree with me on that? Who finds it easy to find answers to these questions? How do you find answers? Go on, Niall, do you want to tell me? Boost variant? Okay. Okay, well, thanks very much for that. I will get on to Boost Python. So Niall is saying quite correctly that you look in the distribution and you'll find code examples. And quite often the documentation is auto-generated to include those code examples, and it's linked through. Not always. Something like the Spirit library, which I will talk about, that is the case. The code examples are there, and the documentation generation is from those examples. So you've got simple working examples. Not all of the documentation is quite so good. Boost Python's isn't quite so good, or I haven't found it to be quite so good. It's one of the older libraries. How big is Boost? 169, the compressed download, source download is 79 meg. It takes about 10 minutes to uncompress on this machine. And when you uncompress it, you'll find there's about 70,000 files in there. So there's quite a lot of stuff. Just to make the point again, a lot of the time you can get rid of Boost by just doing a text substitution. This probably worked for something like shared pointer. That's now a standard shared pointer. So you can just, that's rather nice. You've not got that dependency there. Similarly for unordered containers. And sometimes Boost kind of disappears because something in the language makes a clever piece of functionality it offered no longer relevant. So I'm reminded a bit of Mary Poppins. The Boost library kind of parachutes in on the wind and then blows away again when she's no longer needed. So here are a small subset of the things that you may be using in the standard library that, from my understanding, grew up in Boost. So we've already spoken about variant. Niall said he doesn't like Boost variant. There's a standard variant, which is did you say you liked it or didn't like it? Oh, Boost Spirit you don't like. Sorry, I misheard you. Okay. Okay, I'm interested to hear what you say about Boost Spirit because I'm coming onto that as the first code example. And interested to hear what anyone else has to say. It's certainly something that we use and use to good effect. I guess you can see from this that it's a strange mix. Apart from file system and thread are the kind of things that they're more sort of operating system related, and they're more the sort of thing that people have been crying out for. The other things are things you could do by other means, but nonetheless, Boost has really moved the language forward with things like optional and variant and tuple and bind. Regex is another one where this is something that's commonplace to most languages through the standard libraries, but it took Boost to bring it into C++. And there are lots more. I just did a quick scan. I don't claim to be an expert. I couldn't think of many things that dropped out, but you used to have this pattern of deriving a class from non-copyable to make it a non-copyable class, where you can do it by deleting copy constructors now. And Boost.Assign is a way of creating a container with values in it without using initializer lists, because it was done before initializer lists existed. A quick grep of our code. These are the Boost libraries. These are the kind of the top level headers we're using. That's by no means the full suite, but I think it's most of the ones that apply to the domain that we're in. You've got things like program options as a command line API generator. You've got a graph library. You've got archive for serialization. You've got many different flavors of algorithms for working with strings, all the kind of, does a string start with this, that kind of function, or case-insensitive comparisons. Progress, a little utility, I think, that prints progress to progress of an operation to the output. The highlighted ones are the ones that I was going to talk about in a bit more detail. Using Boost, a lot of the libraries are header only, not all of them. Options for building and installing. I would have liked to have gone to the package manager talk this morning. Did anyone go? I don't know if that's one option. Boost.Build. Boost comes with its own build system. Or you can just integrate the code into your own project and build it as source code, the source libraries. We go for the middle option. We use Boost.Build and we install Boost on our machine, different versions in different places. And we kind of connect the compiler to the libraries and headers like that. So essentially, we run a command that looks a bit like this on Windows. So it's installing Boost, and then we tell Visual Studio where to find the headers, and it uses auto-linking to find the libraries, and it's quite straightforward. We use something very similar on Linux. We just have the libraries built using the standard Boost.Build system, and we set the include path and library path. Takes a while to do this. What we tend to do is do it on one machine and then copy it to others. Might seem a bit amateurish, but that's the way we do it. Okay, Boost Spirit, this has already got a downvote. And it was something that I mentioned in my interview, I think. I said, you can have, it's an idea that you see in a number of the Boost libraries, where they're looking at the opportunities that operator overloading gives you. So we've actually seen that already. We've seen the pipe operator, meaning not bitwise OR, but meaning pipe this range into that range. Boost Spirit takes that idea, so it's looking at, well, let's see what it's looking at. So you write your grammar that you want a parser for in C++, and you're leaning on operator overloading to do that. And due to the limited number of operators and where they can be placed, it's not quite the same, but it's close. Going back to my SNOMED stuff again, we've seen a few of these, but there is a grammar to these SNOMED expressions. Clearly there is. That's based around juxtaposition of pipe symbols, colons, braces, brackets, equalities. So you have a focus concept that's got a concept ID, and then optionally, in fact, a term that's within these pipe symbols. Then a colon there that says this is going to be followed by optional again, maybe followed by refinement. So this is talking about a procedure which is refined by saying it's an excision, and the procedure site was an ovarian structure. I'm still a bit squeamish when I read medical stuff, but I work with a lot of medical people, and they just don't seem to notice this stuff. I don't want to have my ovaries excised. And that's specified. I haven't included the full specification. This is an EBNF. It's saying the rules for building up these expressions. And you can see that WS means white space. So you've got sub-expression is where they start, is a focus concept, then optionally followed by white space, a colon, and white space, and a refinement. And then if you look for refinement, well, it's actually off the screen, I think. It will say how that's built up from all the other things. So I wanted to quickly show some source code. Is that at all readable, or do I need to up the font? Okay. So this is the kind of the spirit magic here. It's writing those same rules, those same grammatic productions, if you like, using native C++ operators. So you can see that a term has a pipe character, which must then be followed by one or more characters which aren't a pipe operator, followed by another pipe operator. So you remember that piece of text within the pipe, not pipe operator, pipe character. And you can see a concept is an 8-byte unsigned integer, which must be followed by a term. This is a very reduced subset, partly because they didn't want me to show all the code, but more because there'd be way too much to take in. But nonetheless, with about double this amount of code, you can have a fully fledged, very readable grammar that will parse SNOMED expressions. And it is kind of magic to me. It's very... Has anyone else used this stuff? Okay. How do you feel about it, Jez? Do you like it, or does it get on your nerves?
No, I think this is a later version of Spirit, but once I accepted the magic, it was great. For quite a long time, that's why it was perhaps trying to understand it.
Whoops.
I first accepted that I had the EBNF here, and I could transcribe it more or less directly into the code. And I was doing
I think I remember, actually. I think we corresponded. I was on that, I think, Spirit Classic, and I think the library has grown up in terms of its practicality. I think it's a lot quicker now. It's quicker to compile, and it's quicker to run.
But once I accepted that, I just had the EBNF and if I had star at the end of this one, I put star in the front, I think, and the 7 plus.
Yes, exactly that, yes. So the plus there, which we're all used to in regular expressions, it means, one or more. Yeah. I think you can see that the rules that we've got, they're not directly the same as the ones on the official standard. It is an effort deriving this parser, but once you've got it, it doesn't change. They're not changing this particular grammar. It's specified, and like you say, it does just work. I was just interested, Niall, what were your downers on this particular library?
Right, so firstly, I tried to do something way too complicated. So I'll tell you what I was doing. I was taking language symbols from the Microsoft compiler and the GCC compiler, and from that I was building out a partial AST with the indications where there was variability in interpretation into the partial AST. And from that I was integrating that into
Yes. So, like Niall's saying, we want to be bootstrapped by Boost, not, trapped by it. Don't use it because it's clever. Don't use it because use it if it works for you. I wanted just to show how long this particular thing takes to compile. So we've got a small file there. If I try and build that, I had to reboot my machine. If I touch the source file. So it's now compiling what looks like a 5K or 6K file. This is quite surprising. I really don't know how long it will take. There is variability in this depending on how sort of warm various bits of the system are. And as you saw, it was quite a simple one. The only mitigation I've got is to say that this grammar is not going to change. This piece of code, there we go. So quite a long time. But then how much code would it have been to write out that grammar longhand? How many bugs might there have been? How many opportunities are then to go and sort of hack it and make it less pure? I'm offering this as an example, and it's one that I was quite surprised to see being used. And not only do we use Spirit, it has a second half to it. It's sort of themed on yin and yang. There's a parser part called chi, and there's a generator part called karma, which allows you to go from the abstract syntax tree to the text format. And it's using the exact same techniques. Where is it? So yeah, this code probably looks like what you were just looking at, but this is going in the other direction. It's producing output via a kind of output generator grammar. I should probably move on from Spirit now. Boost Python. This enables, so it says, seamless interoperability. So as I pointed out before, we have an engine that's in C++, an application in Python. How do you get a dynamic language to talk to a kind of native compiled language without loads of stuff getting copied and loads of overhead, and without having to write loads of code and manually increase references on Python objects? That's what the Boost Python library does for you. It comes up with this in the documentation. This is the kind of thing that makes me a bit nervous. Not all of it, but this bit, it's the library's use of advanced metaprogramming techniques simplifies its syntax for users. I like the simplifies its syntax, but I would rather it said the library's use of transparent, bog standard techniques simplifies its syntax for users. I guess dream on, but the wrapping code takes on the look of a kind of declarative interface definition language. That is true. The code, again, it doesn't look entirely like C++, but you can read it and you can see what it's doing, and it's very straightforward to map your C++ enumerations, structs, functions into Python using this. Yes, as I said, I wish it didn't have to use the advanced metaprogramming techniques, because sometimes those will those kind of guts of the system will spill out on screen. Generally, you've got something wrong, but, well, you have. What I should say is that there's a new pretender in this space, or not even that new. I think the 11 refers to C++ 11. The main issue with Boost Python, and the reason for creating such a similar project, is Boost. So Boost Python was built on, I don't know, C++ 98 or C++ 03. You have to compile it. It has to work with lots of different compilers. I don't think it's been in any way, I think it's been maintained clearly, but has it been extended to work with the newer things that are moving into the standard library? I'm not sure. I would strongly recommend PyBind 11 as if you're deciding to go one way or the other, have a look at this one first. I think this is maybe a case where we use Boost Python because we use Boost. And there's a degree of, if it's working, we don't change it, and that's absolutely fair enough. But just for doing this talk, I had a quick play with PyBind 11, and I found it more pleasant, and it worked with things like variant types a lot more happily than, which is, you know, variant is a newer feature of the standard library. So, nonetheless, use one of these libraries. I don't think there are any other particular contenders, and Boost Python works, and people use it, and we use it very successfully. And it's not difficult now. The way we design our APIs is that we don't expose complicated C++. We want the APIs to be quite sort of, it's not got virtual methods or all that kind of thing. It's basically structs with fields in them, vectors of structs and operators. That's quite a nice thing for the Python layer to work with and for the C++ layer to expose. And we don't do anything clever in the bindings layers. I think that's the lesson that we've learned. Don't try and do some extra bit of adaptation on the way out. Either do it in the C++ or do it in the Python. Keep the API simple, almost like C. You know, C with vectors and strings is the way we play it. Not everyone's choice. And indeed, we have started moving things in. We do indeed expose a variant type, and that's created quite a lot of difficulty, and I might try and push for PyBind 11. Anyone else using either of these libraries? Which ones in particular? Okay. Okay, so you've experimented with both, but professionally you're using Boost Python. Yeah. I'll show you a code example of that. Oh yeah. Do you know what? Boost did a good job. It persuaded the PyBind 11 people to say, the language has moved on, we can do this better, we can provide a header owned library that will produce smaller binaries, quicker compile times, do all the good stuff. We want it. But they use the same sort of paradigm and style. The PyBind 11 code, give or take a namespace, looks very like the Boost stuff. So Boost has shown the way. And it's not a case where Boost has moved into the standard library. It's a case where Boost has kind of inspired other library writers. And this is even more true of I don't know if anyone's using this Yaz library. Yet another serialization library. So that's based on Boost serialization, which is a way of serializing C++ structures, maybe for passing down the wire or saving to disk. We found Yaz to be better for us because it's using a more modern flavor of C++, but it's almost, the code is almost drop-in replaceable for Boost serialization. The other nice thing about using Yaz for serialization is that we choose when we're going to update it. It doesn't get an update when we update Boost. So that's the thing about Boost being monolithic. If you're updating, and that matters in serialization where versions can be important. So, all right. Yeah, you can see I've got stuff with 11 is PyBind 11. It's generally simpler, but this is about Boost. So I'm talking about these graph structures. I'm just going to increase the font size, I think. So we've got some enumerations, we've got a variant type, we've got features, which are labels on nodes, we've got edges, nodes, and we've got the graph, the annotation graph, which is the text. Then we've got the nodes that are regions in the text, then we've got edges linking them. And we've got one function which is not yet implemented. What does the code to bind that to Python look like? I'm going to skip past the variant stuff for now. Pretty straightforward, really. That's how the enums are reflected. And if you're thinking you could generate that automatically, well, you can. You can use X macros to do that, or you could, so you could use the C++ preprocessor to actually kind of stamp out that code for you. How do you reflect structures? It's really pretty similar. So the stuff in strings is how it appears, like this is C++ code, of course. This is kind of instantiating a class factory of some sort that's going to make these edge objects. They're C++ objects that can be used from Python. So they're Python objects in the C++ world. So you've got a constructor, and then you've been given full read-write access to the fields, and there is an opportunity to sort of rename things or repackage things, but we tend to keep it extremely one-to-one. That's just less confusing, so we keep our APIs. This is not a customer API, this is our internal API between the engine and the rest of the stack. The customer API is a REST API. And then this stuff at the bottom, you have to do some extra stuff for collections, which you wouldn't have to do in PyBind 11 from my experiments. You have to go through an extra couple of hoops and declare some more operators. Does anyone have any questions or comments? Any of the... No? How do you mean? Oh, I see. Let's see how long this one takes to build. I couldn't tell you. It's less, but it's still taking some time. Oh. Yeah. So yeah, that was more like 15 seconds. It also built the PyBind 11 version, but that didn't need an update, so that was mainly down to compiling the Boost stuff. Oops. Okay, I've done the demo. Boost into process we use for a tiny corner of it, really, but we use it to great effect. It's got support for memory map files. And in particular, that's what we use for what we call resources. So remember those tools that we had that were very regional specific. Those are done with memory map files, and we've got native C++ structures allocated within those files. So access to that information is not going through a database of some sort. It's going direct to whatever we've put in there, like could be an unordered map or some sort of hashed container. So we've got rapid access from something that's on the file system and something that can be transferred onto the box, but can then be used like native in-memory structures. Again, I haven't been able to make this very simple. I've got two things that are going on in here. Either we're reading the memory map file and the structures in it into memory, or we're writing. I'll go from the writing bit first. So you make a memory map file, in this case one that's create only. You give it a name and you give it an initial size. And you say you're going to be allocating stuff within here as if it's native memory. You've got an allocator, which is accessed via that file object, that managed map file from the IP here is, the IP is a namespace for Boost into process. So you get the allocator, and then you can construct a string object in that. So I've attached a version to this memory map file, which can then be looked up using that same string. And I've given it a version of ACCU 2019. And I've had to put, so it's a bit like you're constructing a string in this file. And then I'm also constructing a terminology. So that's I'm thinking of the SNOMED terminology, quite a big object. And I'm going to put that there in my memory map file. And there's only going to be one of them. That's what the unique instance means. And I've given it the allocator. That's where it's going to allocate memory. And now I can just load other objects within that file. And then having flushed that file, I can then shrink the size back down just to save on disk space. And then that file is on disk and it's containing those structures, those native C++ structures, ready for use by another process. Is that reasonably clear? So it's nothing that you couldn't do without going to the kind of, whether it be the POSIX memory map file API or the Windows one, but it's all completely portable, and it's given this, as close as possible, this C++ construct and use syntax. So just to show how that file is used, to get the string version out, you just look for it from the file that you've opened, and you get back either a pointer to the version on success and its size, or a null pointer and presumably 0 on failure. And when looking for a unique instance, in this case the terminology, you just do it like that. And then you've got access to those structures within that mapped memory. So nothing that couldn't be done, but extremely nicely packaged up. This is one of the libraries that's extremely well documented via example, starting from simple to hard. I think it gives us a lot. This is an area where your code is otherwise going to have to be quite platform dependent. Okay, that's about as much code as I can. I'm not going to show you how long that takes to compile. I think it's probably a bit quicker. Just some ideas for things that aren't in Boost. I don't want to talk about things that are missing from C++ in general or C++ standard library. These are things that we write ourselves that perhaps one might have liked to see appear, in some natural language. And we could have contributed it, or we could, but I don't think we're going to. We've not done it boostly enough. Yeah, I'm not talking about things like, we don't have a C++ UI. We all know that there's no sort of standard C++ UI framework, or not in the standard library, and there's no standard C++ games engine, or web server, graphics, audio. Just things related to our domain that perhaps if someone was feeling like, you know, a side project, I'm going to put in a Levenshtein distance and the variance of that. So we do a lot of this kind of how close are strings together to each other. Ternary search trees, we use that a lot in spell correction and that sort of thing. Deduplication, hashing things to see if they're close matches. Finding the difference between strings. There's a whole family of streaming algorithms that are quite interesting that we've written. So this is the case where you've got so much information coming through you can't store it all. So how do you find the top K items from a streaming collection when you can't store them all in memory? Some really interesting algorithms. It would be nice to have standard or boost matrix maths. We use Eigen for that, but it would be nice to see it rolled into the Boost family. We write our own, we do use some database stuff, but we go direct to SQLite and SQLite commands. It would be nice if there was something that kind of abstracted that a bit. Don't know why I mentioned string templating. Ed wrote a string templating library. Sorry. You'll have to send that on a tweet or something. Sub key, did you say? SOCI. So there is a very good recommended database ORM in C++ that almost made it into Boost, is the message. But it's sometimes good to get the best stuff that isn't in Boost. You don't have to get everything together. Yeah, there doesn't seem to be a standard sort of JSON thing. That's something, we use that as an output format. And that's pretty much it. I've talked enough. Does anyone have any questions? I don't know your name. Mm-hmm.
Do you move to standard libraries as soon as they become available, or do you stay on?
We don't move as soon as they are available. We sort of piggyback it on other changes. We almost no, we're still using Boost file system. We're probably still using quite a few Boost variants and unordered maps. We don't. Things like smart pointers is one where I think we just sort of did go in and do that wholesale replacement, and but generally not. It's almost something that will come up in code review. You know, tidy up this piece of code while you're there, or put it in. And sometimes you might want to do a little bit of qualification and checking. I mean, it could well be that a Boost unordered map remains quicker than a standard unordered map. So if you're really leaning on that as a performance container. I like to move stuff into the standard library because I find the standard library, obviously it's supported directly by the toolchain, and I find the kind of online standard library documentation has just become so good now and so sort of clear. And it's just, it's a better place for it to be if possible, but we certainly don't proactively say, that's it now, file system's in, we're gonna switch the code base. That has happened. There have been buggy implementations of standard regex, and I'm sure that's not the case anymore, but certainly not where I am now, but where I was before, we couldn't do that swap because the standard regex support on GCC wasn't good enough, didn't pass the tests, possibly didn't compile, I can't remember. But that's the only sort of thing, if it didn't pass our kind of qualification standards. Any more questions or comments? Hi.
You mentioned JSON, so do you use Bootstrapped?
It's not quite up to the job. We use, there's a really good JSON serializer in Yaz that's just come in, that's quicker. Property tree tends to convert numbers into strings. So it's limited. It might be of some, no, we don't use it. It's not good enough for us. We haven't found a way to get proper JSON out from it. So be careful if you are using it. You might, and check that stuff you meant to be a number is not a string when it comes through the property tree. Any more? Hi.
So sometimes you find like little utility classes or objects which kind of are useful, but you kind of, there's this whole dependency on this entire library. You feel that that's the case sometimes?
I think we use Boost as an extension of the standard library. That's pretty much, we use everything in there that helps our code. We regard the Boost code as better than we could write ourselves, better supported. And I don't mean, it just bootstraps the whole product. But it's not like it's a framework we're working within. It's not like something like, say, a Django application in Python or we are writing a library. Our core product is a library that's used in a web server, I suppose, and we are using the Boost libraries to help provide support for algorithms, all the things I've been talking about, a massive array of things, just like we use the standard libraries. That's how we use it. Any more? Okay then, well, enjoy the rest of the conference. Thanks very much for coming, and press the green smiley button. I think that's what you're supposed to do on the way out.